6.2, the unit circle and circular functions. So we've talked about the unit circle before, but let's just remind ourselves what that is. So a unit circle is a circle with a center at the origin and a radius of 1. So if we have a radius of 1, I'm just going to put r here, and let's make it r equal to 1, theta. Well, we're going to point out, first of all, if r is equal to 1, then we know at the quadrantal angles what the value, the x and y values are going to be. We have 1, 0, 0, 1, negative 1, 0, 0, negative 1. So just at our quadrantal angles. Also, we can point out something. If you remember, the length of the arc S is equal to r theta, where theta is in radians. If r is equal to 1, so on the unit circle, r equal to 1, then S is equal to theta, meaning that if we know the length of the arc, then we can substitute that in place of theta in the trigonometric functions. So we can do the sine of S, cosine of S, tangent of S, cotangent S, secant S, and cosecant S. And what do we know about those? Well, we know that we can relate these all to x, y, and r. R is equal to 1, so that's going to simplify this. So sine of S is x over r, is y over r, and therefore, since r is equal to 1, it's just y. Cosine of S, x over r, so x. Tangent of S, y over x. Cotangent of S, x over y. Secant of S, 1 over x. And cosecant of S, 1 over y. So if we know a point on the unit circle, then we can easily fill in all of our trigonometric ratios. Now I'm going to point out too with this, that if we look at this, and look at that y, and this is x, we should realize that any point on this unit circle being defined by x and y with a radius of 1 can be given by x squared plus y squared is equal to 1. So that is the equation of the unit circle. Which is kind of handy to know. In fact, x squared plus y squared equal to 1. X is cosine of S, y is sine of S, so that is cosine squared S plus sine squared S is equal to 1, which if I just simply rewrite that, we have sine squared S plus cosine squared S is equal to 1, which you remember as one of our Pythagorean identities for trigonometric ratios. Sine squared plus cosine squared is equal to 1. So pretty cool. So that is based on the unit circle and the knowledge that we have of the unit circle. So now what I'd like to do, since we can substitute S in for theta, I'd like to use S as a reference angle and see what happens in each of the four quadrants. So let's get this out of the way. Now let's say S equal to pi over 3. So what I'm going to do is I'm going to create some columns here. So we're going to have our S, and really I should say that's our reference angle S, so I'm going to say S of R just to state that's the reference angle S, because S is going to be in 4 different quadrants. So let's do the quadrant. So obviously 1, 2, 3, and 4. Well, starting out, if the reference angle is pi over 3, then S in the first quadrant is going to be pi over 3, because the reference angle is always the angle in the first quadrant. In the second quadrant, it's going to be, remember we said reference angle was, for the second quadrant, or I should say the angle in comparison to the reference angle for the second quadrant is 180 degrees minus the reference angle. Well, remember that in radians, 180 degrees is pi, so it's going to be pi minus the reference angle, so that's pi minus pi over 3, which gives us 2 pi over 3. In the third quadrant, pi plus pi over 3, which gives us 4 pi over 3. And then in the fourth quadrant, it's going to be 2 pi minus pi over 3, which that's 6 pi over 3 minus pi over 3 is 5 pi over 3. So those are our angles, and those are the quadrants associated with it. So next thing I'm going to do is I want to look at symmetry. Symmetry and the corresponding point. So actually I'm going to put symmetry here, and I'm going to put corresponding point. Okay, so what that corresponding point is going to be is it's going to deal with pi over 3, what is cosine S and what is sine S. Right, so that's going to give us our corresponding point. So we're going to have that. Symmetry is how does that quadrant relate to that original corresponding point. If you think about it, what happens? If we're in the first quadrant, symmetry, there is no symmetry to that point. It's not applicable because we're at that point. When we go into the second quadrant, what we're really doing is we're taking that point and we're flipping it over the y-axis. So symmetry is with respect to the y-axis. Then, to get to the third quadrant, we're flipping it over the y-axis and flipping it over the x-axis, which is basically it's symmetric with respect to the origin. We're negating both x and y. And then the fourth quadrant, we're just flipping it over the x-axis, so it's symmetric with respect to the x-axis. So if I know my sine and cosine of pi over 3, well, what's pi over 3? Pi over 3 is the equivalent of 60 degrees. So if I look at that and go, okay, well that's the equivalent of 60 degrees, so I'm going to go pi over 3. That's 1, 2, square root of 3. So if we have 1, 2, square root of 3, then cosine of pi over 3 is 1/2. and sine is square root of 3 over 2. So just pulling it right off of that. So now we can find all these other points just by doing the necessary flipping. Flipping over the y-axis means that x gets negated, y stays the same. Negative 1/2 square root of 3 over 2. Origin, we negate both of them. Negative 1/2, negative square root of 3 over 2. X-axis, we negate the y value. 1/2, negative square root of 3 over 2. So we have the corresponding points. And we really, at the same time, just found cosine of s and sine of s, because cosine is the associated x value and sine is the y value. So 1/2, negative 1/2, negative 1/2, 1/2, square root of 3 over 2, square root of 3 over 2, negative square root of 3 over 2, and negative square root of 3 over 2. So pretty cool. That wasn't that hard to find from this. So all we did was we said, okay, we've got this reference angle. Let's find all the different angles that we can have in our four quadrants and determine what happens with the points associated and what that gives us for cosine and sine in those quadrants. So a pretty handy trick, and there are times where you would need to use this, and there are other times where you go, why did I even bother? But that's life. So, pretty cool to know. And you can do this exact same thing for any arc length S on the unit circle. You can go through and find these and get the corresponding points, etc. Works really easily when you're dealing with our standard angles, pi over 6, pi over 4, pi over 3, or 30, 45, and 60 degrees as our reference angles. So that's pretty cool. Now just remember that when we're dealing with the unit circle, x and y both represent points on the unit circle, and therefore x must be in between -1 and +1, and y must be between -1 and +1 inclusive, because if you look working your way around the circle, you start at x equal to 1, x goes to 0, x goes to -1, x goes to 0, x goes to +1, and you start at y equal to 0, y goes to 1, y goes to 0, y goes to -1, y goes to 0. So working our way around. And I should note that obviously when we were doing our trigonometric ratios, the denominator cannot be allowed to be equal to 0. So when we had 1 over y and 1 over x for cosecant and secant, obviously the denominator is not allowed to be equal to 0 in that case. Okay. So let's look at the domains of circular functions. Okay, so the domains of circular functions, really that's saying, well, what can we put into it? And it should be obvious that sine and cosine, we can plug anything into those because that's going to be x or y. right? So sine and cosine. The domain is from negative infinity to positive infinity. That should be a given. Well, what happens when we deal with tangent and, well, let's just start with tangent. Well, tangent was y over x. So that means that we can't allow x to be equal to 0. When is x equal to 0? X is equal to 0 at 90 degrees, or pi over 2, and 270 degrees, or 3 pi over 2. So basically, we can say that for tangent, and the same thing happens for secant, that the domain is all s such that s is not equal to 2n plus 1 times pi over 2, where n is any integer. Now, what's that doing? That's basically, remember I said it's pi over 2, 3 pi over 2. That makes it, if we keep going around, 5 pi over 2, 7 pi over 2, 9 pi over 2, 11 pi over 2, right? So 2 times n, if n is an integer, is always going to give us an even number, plus 1 is always going to make it so it always gives us an odd number. So that's going to say, that's just saying that this can be anything, like I said. It can be any odd multiple of pi over 2. Now, if we're dealing with cotangent of theta, and the same works for cosecant of theta, because we run into the problem that with those, you have over y. Cotangent is x over y, cosecant is 1 over y. So we can't allow y to be equal to 0. Well, when is y equal to 0? At 0 radians, at pi radians, at 2 pi radians, 3 pi radians, 4 pi radians, 5 pi radians, right? So it's multiples of pi. So that's all s such that s is not equal to n pi. N is an integer. So there we go. So that gives us our domains, and this will become very important when we're graphing trigonometric functions, to realize that we have these domains, and so we're going to run into asymptotes at certain points when we're dealing with tangent, secant, cotangent, and cosecant. So really handy to keep that in mind. Okay. We get that out of the way. And let's evaluate a circular function and doing some things that we may know of. Now, when we're dealing with this, remember, we're dealing with radians. So you want to make sure that your calculator is in radian mode, not degree mode. Because you're going to come up with some really strange answers if you are in degree mode. Because if you think about it, all the way around the circle is 2 pi. That's 6.28 approximately, which is a very small, relatively small degree measure. So if you're looking at 0.6 radians, 0.6 of a degree is just going to be a bare smidgen on there. So just make sure that you're in radians. Okay, so first, let's find some exact values. Let's find the exact value of sine of negative 3 pi, cosine of negative 3 pi, and cotangent of negative 3 pi. Well, there's a couple things we can do with this. One, we can find coterminal angles, right? Negative 3 pi, if we want to get to the least positive coterminal angle, then what we can do is if it's negative, we can start adding 2 pi to it. So if we add 2 pi, we get negative pi. If we add 2 pi, we get positive pi. So that's really saying, what's the sine of pi? What's the cosine of pi? What's the cotangent of pi? Well, where are we at pi? At pi, we are boom, on the other side. X is equal to negative 1. And y is equal to 0. And theta is equal to pi. So what's the sine of pi? Well, that's y, so that's 0. What's the cosine of pi? That's x, negative 1. What's the cotangent of pi? That's x over y, or cosine over sine, negative 1 over 0, that is undefined. So undefined. So that wasn't so bad. Now let's plug some values into our calculators. Remember, make sure your calculators are in radians. And let's approximate the following. Sine of 3.42 radians, tangent of 0.8234 radians, secant of 5.6041 radians, and cosecant of negative 2.7335 radians. Now, I would suggest plugging these into your calculator. Okay, that's what I'm going to do. Make sure that you're in radians. So I'm putting myself into radian mode right now. Now my calculator says rad, so that's pretty cool. You thought I was going to say rad. Okay? So now that I have that, I can find these values. So the sine of 3.42, I'm just going to plug in 3.42 and take the sine of it. And I get that is approximately negative 0.2748. Tangent of 0.8234. So 0.8234, we're going to take the tangent of that. And that is approximately 1.0790. Secant, my calculator doesn't have a secant button. Your calculator doesn't have a secant button, but it may have secant in a math menu in there somewhere. If it does, more power to you, take it straight away. But I don't, so I know that secant is the reciprocal function of cosine. So I can say that is equal to 1 over cosine of 5.6041. So the cosine of 5.6041 is 0.778147, etc. And if I take the reciprocal of that, I get 1.2851 approximately. Again, secant is the reciprocal of sine, so I can say that's 1 over sine of negative 2.7335. So I can plug that in, 2.7335, the negative of that. We're going to take the sine of it, which gives me about negative 0.39685933, etc. And I'm going to take the reciprocal of that, which gives me about negative 2.5198. Remember to round, do not truncate. That was negative 2.5197, I believe. So make sure that you're rounding, not truncating. Well, let's reverse the process. We can still do the same things with radians that we can do with degrees. So let's start with the ratio or the calculated value, and then reverse the process to get the radian measure. And I'm going to be specific about what intervals to do this in. So I want to approximate the value of s in an interval from 0 to pi over 2. And I can do that inclusive. Now, why is it important that I indicate the interval? Because remember, all students take calculus. My trig functions are going to be positive in 2 of the quadrants and negative in 2 of the quadrants. So if I don't state which quadrant I'm in by giving this interval, then we don't know which value to use. So in that case, we would have to say, I could give the full interval from 0 to 2 pi, or from negative pi to positive pi, give a full cycle, and you could find the values in that range, which you'd have 2 possible answers for it. But I'm going to break it down to 1 quartile by giving you this. This is from 0 to pi over 2 is from 0 to 90. That's the first quartile, right? So I'm just going to indicate here, that's the first quartile. We know that. All the values of the trig functions are going to be positive. So if the sine of s is equal to 0.3210, so I want to find s. Well, how do I find s? I'm just going to take the inverse sine. Inverse sine of 0.3210. Now remember, you have to be in radians if you're going to do this, because s is in radians. Technically, if you weren't in radians, it would give you the answer in degrees. You could convert from there to radians, but right now we're dealing with radians, so work within radians, make sure your calculator's in radians. Always be careful as you're doing these things, look and determine what you should be using, whether degrees or radians, and make sure that you put your calculator appropriately, so you don't end up with really strange answers. So we have 0.3210, and I'm going to take the arc sine of that, which is approximately 0.3268. 0.3268. And that's in the first quadrant, so that's not just the reference angle, that actually is the angle. 0.3268 radians. So let's try this one. What if we have the interval from 3 pi over 2 to 2 pi? 3 pi over 2 to 2 pi, that's the fourth quadrant. Just going to put that there as a little reminder, right? And we know the tangent of s is equal to negative square root of 3 over 3. And I'm actually going to say I want the exact value of s. Now we should look at this. Well, first of all, fourth quadrant, tangent is negative in the second quadrant and the fourth quadrant. So this is negative. So we can do this, and this is going to give us an angle. We're going to have to treat that as something that will give us the reference angle so we can get into the fourth quadrant. Who knows? It might get us there, but really we can ignore this negative sign initially. And we can drop our marker on the floor. Luckily I have another one. So I'm going to ignore that negative sign initially and go, wait, I have square root of 3 over 3. Remember, tangent is y over x. So tangent is y over x. If we're in the fourth quadrant, so I can even pull it from this, I can say, if we're in the fourth quadrant, then y is going to be negative, x is going to be positive. So I can break this down and say, well, square root of 3 over 3 negative of that is going to be, and I'm going to shift this because I know where I'm in the unit circle, I'm going to put this as it should be, which is 1 over the square root of 3. Since y is going to be negative and x is going to be positive, y is equal to negative 1, x is equal to square root of 3. Well, where do we have square root of 3 and negative 1? Well, again, if I ignore that negative, what value or what angle gives us square root of 3 and 1? Well, if I look at my triangle 1, 2, square root of 3, that would be 60 degrees, right? Opposite over, sorry, flip that. That would be 30 degrees, which is pi over 6. So pi over 6, opposite over adjacent, y over x. So my drawing of that is not pretty, but it allows me to figure out what that is. So I'm looking at pi over 6 as my reference angle. If I'm in the fourth quadrant, then my reference angle pi over 6 is going to be 2 pi minus pi over 6. 2 pi is 12 pi over 6, so 12 pi over 6 minus pi over 6 is 11 pi over 6. So S is equal to 11 pi over 6. And that's going to be the end of this video on the unit circle and circular functions. There will be a second part.